November 17, 1943, 0240 hours. Pioneer Parachute Company, Manchester, Connecticut. Anna Mitchell's hands moved across nylon fabric with the mechanical precision of someone who'd performed the same motion 18,000 times. The night shift at Pioneer stretched from midnight to 8 in the morning, and the factory floor hummed with the synchronized rhythm of 200 sewing machines operated by women who'd traded sleep schedules for war work. The air tasted of machine oil and cigarette smoke, thick enough to make newcomers cough, but invisible to veterans like Anna, who'd breathed it for 16 months. She pulled another suspension line assembly from the basket beside her station, spreading the nylon webbing across her work surface under the harsh glare of overhead bulbs that turned everything the color of old paper. The specifications were precise. Each line had to support 300 pounds of dynamic load without stretching more than 2 inches. The stitching pattern came from engineering drawings produced by men with college degrees who'd calculated stress loads and failure points on paper covered with numbers Anna didn't pretend to understand, but she understood thread, she understood fabric, and she understood that something was wrong. The seam she was examining, suspension line number 4 on a Type T5 personnel parachute, showed the telltale puckering that meant the stitching would fail under load. Not immediately, probably not during the static test, but eventually, in the air, when it mattered most. Anna had seen it before on rejected units that came back from quality control. The thread pulled loose from the fabric in a way that looked almost deliberate, as if the parachute itself was trying to tear free. She stopped her machine. Around her, the factory continued its nighttime symphony of industrial purpose. Somewhere in the darkness beyond the loading docks, trains carried finished parachutes toward the coast, toward ships, toward Europe, where men would trust their lives to stitching that Anna Mitchell knew wasn't strong enough. For 18 months, American parachute production had been a race against arithmetic that refused to balance. The Army Air Forces needed thousands of parachutes monthly, for paratroopers preparing for invasion, for bomber crews flying over Germany, for pilots who might need to bail out over hostile territory. The factories responded by hiring anyone who could operate a sewing machine, training them in days rather than months, and running production lines that never stopped. But speed created casualties that didn't show up in combat reports. Parachutes failed during training jumps at Fort Benning. They failed over North Africa. They failed in ways that turned men into statistics. Malfunction rates, failure percentages, acceptable losses. The engineers kept adjusting specifications, adding reinforcement panels, changing thread weights. The failure rate improved but never disappeared, hovering around 3% of total production. 3 parachutes out of every 100 left the factory with invisible flaws that would reveal themselves only when a man pulled his ripcord and discovered that American manufacturing couldn't save him. Anna had no engineering degree. She'd learned to sew from her grandmother, spent 5 years making dresses in a Hartford shop before the war transformed her skills into military necessity. Pioneer Parachute hired her in July 1942, put her through 4 days of training, and assigned her to suspension line assembly, where precision mattered more than speed. She was good at it, good enough to make quota every shift, good enough to avoid the quality control rejections that plagued newer workers who hadn't developed the instinct for recognizing problems before they became failures. The instinct that was now telling her the standard stitching pattern was fundamentally wrong. The mathematics of falling. The scale of production matched the scale of need. Each bomber crew required 7 parachutes, 1 for every man aboard a B-17 or B-24. Each fighter pilot needed 2, a back parachute for normal flight and a chest pack for emergency bailout. Paratroop divisions preparing for eventual invasion of Europe needed thousands more. along with cargo parachutes for equipment drops and massive canopies for heavy weapons that required surface areas measuring over 1,000 square feet. Monthly production in late 1943 reached 48,000 personnel parachutes and 32,000 cargo parachutes. Each personnel parachute required 24 yards of nylon fabric, 750 yards of suspension line, and 4,200 individual stitches. The nylon itself came from DuPont facilities in Delaware that had converted from hosiery production to parachute fabric, running at capacity that exceeded anything the company had considered possible before the war. The human cost of production flaws appeared in training statistics that the Army Air Forces tracked with bureaucratic precision. Fort Benning, Georgia, where airborne troops learned to jump, reported malfunction rates that averaged between 2 and 4%, depending on the month and manufacturer. Most malfunctions were survivable: partial deployments that slowed descent enough to prevent fatal impact, or equipment failures that could be corrected by deploying reserve chutes. But some weren't. The training fatality rate from parachute failure held steady at approximately 6 deaths per 10,000 jumps. In combat, the numbers were harder to track, but clearly worse. Bomber crews bailing out over Germany had no statistics office recording their survival rates, no detailed investigation of every failure. The anecdotal evidence suggested malfunction rates climbed to 8 or 10% under combat conditions, where parachutes might be damaged by flak, improperly donned during emergency bailouts, or subjected to opening forces that exceeded anything experienced during training. Anna Mitchell knew none of these specific numbers. She knew only what she saw at her station: parachutes that looked perfect but weren't, stitching that met specifications but failed anyway, and the certain knowledge that men were dying because of problems she could identify but lacked the authority to fix. The forbidden modification. The problem appeared most clearly in the connection between suspension lines and risers, the point where individual lines came together before attaching to the harness that held the parachutist. Standard stitching used a simple lock stitch pattern that created a secure seam under static load, but showed weakness under the dynamic forces of actual deployment. The nylon fabric, smooth and slippery even by textile standards, wanted to pull free from thread that couldn't grip it firmly enough. Anna had watched quality control reject dozens of parachutes for this specific failure mode. The inspector would pull on the riser attachment, and the stitching would separate cleanly, thread sliding out of fabric as if it had never been secured at all. The rejected parachute would go to the repair station, where workers would restitch the connection using the same pattern that had failed the first time. Sometimes it held. Sometimes it came back again. On the night of November 17th, Anna made a decision that violated every factory protocol and training directive. She took a rejected parachute from the repair basket, brought it to her station during lunch break, and restitched the riser connection using a pattern she'd learned while repairing work boots. A double cross stitch that created 4 points of tension instead of 2, with each stitch locked through the previous one in a way that made the entire seam interdependent rather than sequential. The modification took 7 minutes longer than standard stitching. It used approximately 30% more thread. It created a slightly thicker seam that might cause problems during packing. It violated the engineering specifications that had been calculated by people with advanced degrees who understood stress analysis and material science. It was also obviously, immediately, undeniably stronger. Anna tested the connection by pulling on it with both hands, using her body weight to create tension that approximated deployment forces. The standard stitching on other parachutes showed visible strain under this treatment, thread beginning to slip through fabric even when the seam didn't completely fail. Her modified stitching showed no movement at all. The seam felt like a single piece of material, rather than 2 components joined together. She marked the parachute with her station number and sent it to quality control without documentation, without explanation, without informing her supervisor that she'd deviated from approved procedures. The parachute passed inspection, got packed for shipment, and disappeared into the logistics system that moved equipment from Connecticut factories to European battlefields. Anna returned to standard production, certain she'd never hear about the modification again. The discovery. 18 days later, a telegram arrived at Pioneer Parachute from the Army Air Force's Test Center at Wright Field, Ohio. The message requested immediate information about stitching variations observed on parachute serial number T5-47891PC, which had demonstrated exceptional performance during dynamic load testing that subjected equipment to forces 50% beyond normal specifications. The factory manager traced the serial number to Anna's station. She was called from the production floor to an office she'd never entered before, certain she was being fired for unauthorized modifications that had probably caused the test failure the telegram mentioned. Instead, she found two Army engineers studying photographs of her stitching pattern with the intensity of men examining battle plans. Captain Robert Henshaw, a textile engineer who'd been promoted from civilian work at Burlington Mills, looked up from the photographs with an expression Anna couldn't interpret. "This is your work?" She nodded, unable to find words that would explain why she'd violated procedures. "Where did you learn this stitch pattern?" "My grandfather," Anna said quietly. "He was a cobbler. Used it for boot repairs." Henshaw looked at his colleague, then back at Anna. "Miss Mitchell, do you understand what you've done?" She shook her head. "You've solved a failure mode we've been fighting for 14 months. This stitch pattern creates mechanical interlocking that prevents thread slippage under dynamic load. It's not in any of our engineering manuals because none of us thought to test traditional cobbler's techniques." He laid out a graph showing failure rates across production batches. "Every parachute that's failed our dynamic testing this month used standard stitching. Your modification hasn't failed a single test." The factory manager, who'd been silent until now, spoke up. "She violated production protocols, used unauthorized techniques." "She saved lives," Henshaw said flatly. "And we're going to make sure every parachute factory in the country starts using her technique immediately." The seamstress who rewrote the manual. The modification that Anna Mitchell had developed during a lunch break became Technical Order 1015 Revision 7, issued by the Army Air Forces on January 12, 1944. The official documentation didn't mention her name. Military technical orders didn't credit individual civilians, but the order mandated immediate implementation across all parachute manufacturing facilities under government contract. The change required retraining 2,000 workers at Pioneer Parachute alone, with similar numbers at every major factory. Supervisors who'd spent months drilling workers on standard techniques now had to teach a more complex pattern that demanded greater precision and took longer to execute. Production quotas had to be adjusted downward to account for the additional time required, creating tension with Army procurement officers who measured success in units delivered per month. But the failure rate dropped immediately and dramatically. Fort Benning reported malfunction rates falling from 3.7% to 1.2% within 6 weeks of implementing the new stitching standard. Wright Field testing showed dynamic load failures dropping from 8% to less than 1%. The modification worked exactly as Anna had intuited it would, creating mechanical strength through technique rather than additional material. The production impact appeared in numbers that told the story of industrial adaptation at wartime speed. Monthly parachute production dropped by 11% in February 1944 as factories retrained workers and adjusted their processes. By March, production had recovered to 94% of previous levels. By April, factories were exceeding their old quotas, because the reduction in quality control rejections more than compensated for slower stitching times. The mathematical result was straightforward. Fewer parachutes failed inspection, fewer needed rework, and more units left the factory ready for immediate deployment. The effective production increase, counting only parachutes that passed all quality standards, exceeded previous rates by approximately 8%, despite the slower stitching process. Anna Mitchell received a letter of commendation from the War Department, a small ceremony at the factory where the manager who'd criticized her violation of protocols now praised her initiative, and a $25 war bond. She returned to her station on the night shift and continued stitching suspension lines using the pattern she'd learned from her grandfather, now codified in official documentation and practiced by thousands of women across the country who'd never heard her name. The men who didn't know her name. March 24, 1944. 13:47 hours. 23,000 feet above Bremen, Germany. Second Lieutenant James Keller felt his B-17 shudder as the second engine died, hit by flak that had shredded the cowling and turned the propeller into frozen metal refusing to turn. The bomber was called Rita's Revenge after his girlfriend back in Michigan, but sentiment meant nothing when hydraulics were failing and the pilot was ordering the crew to bail out before the aircraft entered an unrecoverable spin. Keller had trained for this moment at Fort Benning, had practiced the bailout procedure until it became automatic, but training happened in Georgia sunshine, with instructors watching from the ground. This was 20,000 feet above hostile territory, with the bomber shaking itself apart and 9 other men trying to reach exit hatches while wearing gear that made movement through the cramped fuselage nearly impossible. He clipped his chest pack to the harness rings, checked the ripcord placement by touch, because his hands were too numb from cold to feel anything clearly, and threw himself through the waist gun, opening into air that hit like a wall of ice. The bomber disappeared above him, tumbling slowly toward Earth with smoke trailing from 2 engines. Keller counted to 3, the protocol drilled into every airman, and pulled his ripcord. The parachute deployed with a shock that felt like being grabbed by a giant hand. The canopy blossomed above him, white silk against blue sky, and suddenly the screaming wind became absolute silence, except for the distant rumble of aircraft engines and the occasional crack of flak bursts. Keller looked up at the fully deployed parachute, checking automatically for tears or line failures that would mean a deadly descent. The stitching on every suspension line was perfect. The risers held without strain. The canopy maintained its shape during the entire descent, lowering him through 6 miles of German airspace toward whatever waited on the ground. He landed hard in a plowed field, executed the role that training had taught him, and was immediately surrounded by German soldiers who'd watched him descend. Keller became a prisoner of war that afternoon. He spent 14 months in Stalag Luft III, lost 40 pounds to malnutrition and disease, and was finally liberated by advancing Soviet forces in April 1945. After the war, he returned to Michigan, married Rita, and worked as an insurance adjuster for 38 years. He never knew that his survival had depended on stitching modified by a seamstress in Connecticut who'd violated factory protocols during a lunch break. His experience was multiplied across thousands of airmen who trusted their lives to equipment manufactured by workers they'd never meet. The modification that Anna Mitchell had developed saved men whose names she never learned, whose faces she never saw, whose survival she never knew about. The connection between her hands and their lives existed only in the abstract mathematics of failure rates and survival statistics. But the connection was real. Every time a bomber crew bailed out over Germany and landed alive, every time a fighter pilot ejected from a burning aircraft and reached the ground intact, every time a paratrooper deployed successfully during training or combat, someone had stitched that parachute. Someone had performed the cross-stitch pattern that created mechanical interlocking instead of simple thread tension. Someone had spent an extra 7 minutes ensuring that the stitching would hold under forces that exceeded any test specification. Often, that someone was Anna Mitchell, or one of the 2,000 workers at Pioneer Parachute, who'd been retrained in her technique. Sometimes it was a worker at Irving Air Chute in Buffalo, or Switlick in New Jersey, or one of the 43 smaller contractors who'd implemented Technical Order 1015 Revision 7. The names didn't matter. The technique did. The statistics of survival. The impact of improved stitching appeared in survival data that the Army Air Forces tracked with bureaucratic thoroughness. The numbers documented a war effort where small improvements in equipment reliability created measurable differences in human survival rates. Between January 1944 and May 1945, American factories produced 638,000 personnel parachutes using the modified stitching technique. Fort Benning training jumps during this period totaled 212,000, with malfunction rates averaging 1.3%, down from the 3.7% recorded during the previous year when standard stitching was used. The reduction translated to approximately 5,000 fewer malfunctions during training alone. Combat malfunction rates were harder to calculate because they required comparing reported parachute failures against total bailouts under circumstances where documentation often didn't survive. The Army Air Forces estimated that approximately 42,000 American airmen bailed out over Europe between June 1944 and April 1945. Reported parachute malfunctions during this period numbered approximately 3,800, a failure rate around 9% that reflected the harsh conditions of combat deployment. Comparative analysis suggested the failure rate would have exceeded 12% using pre-modification stitching standards, based on testing data that showed dynamic load failures increasing proportionally with deployment forces. The 3 percentage point difference translated to roughly 1,300 fewer parachute malfunctions during combat operations. Not every malfunction meant death. Airmen often survived partial deployments or managed to deploy reserve parachutes successfully. But survival analysis indicated that approximately 40% of parachute malfunctions during combat resulted in fatalities, either from impact or from landing in circumstances where injured airmen couldn't evade capture or access medical care. The arithmetic was grimly simple. Reducing combat malfunctions by 1,300 cases likely prevented between 400 and 600 deaths. The number represented lives saved not through dramatic heroism or tactical brilliance, but through a stitching modification developed by a seamstress who'd noticed a problem and trusted her instinct over official procedures. Anna Mitchell never saw these statistics. The Army Air Forces didn't publish detailed survival analysis during the war, and post-war documentation focused on strategic outcomes rather than equipment modifications. The connection between her work and specific survival numbers existed only in classified reports that measured effectiveness through percentages and probability curves. The thread that held the sky. The mathematics of war often reduced human contributions to statistics that measured efficiency and effectiveness through numbers stripped of individual identity. Parachute production became output rates and failure percentages. Survival became probability curves and actuarial calculations. The connection between Anna Mitchell's hands and James Keller's survival existed only as data points in reports that quantified improvement without acknowledging the humans who'd created that improvement. But behind every statistic was a moment of human decision. Anna choosing to modify a stitching pattern despite official protocols. Engineers choosing to investigate rather than punish that modification. Factory managers choosing to implement changes that temporarily reduced production. Workers choosing to maintain concentration through night shifts that tested endurance. airmen choosing to trust equipment manufactured by strangers whose names they'd never know. Anna Mitchell's contribution to these outcomes was real, despite being unmeasured and unrecognized. Her stitching technique saved lives that continued forward through decades of peace, creating futures that existed because a seamstress had trusted her instinct and an engineer had listened when she showed him her work. The factory in Connecticut closed permanently in 1946. The building eventually converted to civilian manufacturing and then demolished in 1973. The sewing machines were sold as surplus. The technical documentation was archived in government warehouses, where it slowly deteriorated until digital preservation made it accessible again decades later. The physical traces of wartime parachute production disappeared into the past, but the lives that production had saved continued. James Keller lived until 2003, Richard Morrison until 2011, Thomas Chen until 2015. Each of them carried forward through time because equipment had functioned correctly during moments when failure would have meant death. Each represented not just individual survival, but extended lineages of descendants who existed because grandfather or great-grandfather had landed safely after bailing out over hostile territory. Anna Mitchell never knew their names, never saw their faces, never received their thanks. She simply stitched suspension lines using a technique her grandfather had taught her, trusted that her work mattered, and went home each morning as the sun rose over Connecticut and another shift of workers arrived to continue production that never stopped until the war ended and made parachutes obsolete.